branding will still be there. There's no risk that someone can forget that they're using an HP when every time they log into the management interface, there's a large HP logo. So vendors have added all kinds of additional functionality, and this includes the ability to manage system firmware updates without having to run applications on the system. You can log into the web UI that's presented, and you can upload a new firmware image, and then it'll reboot the system, apply that, and everything will just magically work. Rather than serial over LAN, which is not really such a great way to manage Windows servers, you can have a virtual keyboard monitor. So you click a button, and then a Java applet pops out and connects over something that is often, I can't believe it's not VNC. Connects to a service that's running on this IPMI controller that is hooked into the GPU on the device, and then scrapes the contents of video memory out of that, displays them to you, and then fakes up a USB keyboard and mouse. So you can sit there, and through the Java applet, you can control your system. So you can manage a pointy, clicky installer. And sysadmins love that as well. You have a fake CD drive. So if you want to install something, but you've neglected to actually set up any kind of NetBoot infrastructure because you're a lazy sysadmin, just a quick question. A sysadmin is considered a protected class. No, I'm not violating the code of conduct here, am I?
Laziness is a virtue.
Right, laziness is a virtue, I'm told. So I'll go with that. So you can upload an ISO to the controller, and it will then make it appear as a fake CD drive. There's magic discoverability features, so you can plug in a BMC, and then it might actually be running a UPnP server. So your systems running UPnP listeners can then say, oh, this BMC just appeared. Click here to manage your enterprise server. And none of this is in the IPMI specification. So almost all the fun stuff is completely unspecified, and vendors implement a lot of it themselves, and so it's all slightly different and gratuitously incompatible and really, really fun. There's a lot of additional complexity here. If you look at the inner workings of one of these devices, you'll typically find that there's a large piece of user space code that's managing the IPMI protocol stack. It's sitting there bound to a network port, but it's also listening to a link between the server and the IPMI controller, or the BMC, or baseboard management controller, which is this device that's sitting here providing all the IPMI functionality. It's sitting there listening to that, and then you've got some sort of brilliant user space IPC that's sometimes over sockets and sometimes over things that are worse than sockets. And they're talking to each other, and then sometimes they've actually moved ARP handling out of the kernel and put it in user space as well. I figured this one out after TCP dumping an IBM BMC and wondering why the trailing end of ARP who has packets tended to contain code. Thankfully, not kernel code, but it was leaking chunks of the IPMI management daemon over the network every time it sent an ARP request. That's just going to give you a flavor for the rest of this presentation. The Magic GPUs are amazing. Most of them look like Matrox G200s, except with different PLL setup, because everybody loves PLLs. These are things where from the operating system side, they look like a PCI device that is a roughly Matrox compatible chip. From the BMC side, they're this strange window where you read some registers and it tells you what resolution the operating system has set. You can magically infer, it presumably magically infers that from program timings and stuff, and then you just read these values out, and then you know, well, okay, I read this block of memory and that's the screen, and then I can just pass that off to my Java applet. And there's a magic device node for you to do all of that from. It's incredible. I love this stuff. There are web services which are not necessarily limited to just the web UI, although obviously they're the web UI, but there are often management interfaces, scriptable things, devices, endpoints where you can throw XML or JSON or XML in JSON or JSON in XML in JSON. and then things happen, and what those things are is sometimes documented and sometimes not. And so often, a lot of the things that you can do through the pointy-clicky interface, there's also a scriptable interface over the web management interface, and everybody does that differently. And there's a lot more, and I'm not going to go into it because I will run out of time, I will actually start swearing, and I do not have anything to drink here. So what's a BMC? A BMC is this, as I said, the baseboard management controller. It sits on, it used to generally be a plug-in card. These days, in order to save money, it's normally integrated directly onto the server motherboard. It's a complete small embedded computer. And when I say small, these days they're on the order of 600 to 800 megahertz CPU, 256 megabytes of RAM, often a significant quantity of flash because they need to be able to store this ISO image that you've just uploaded. So usually at least a DVD's worth of flash so that you can upload an entire Windows installed DVD. In almost all cases, they're running Linux. The CPU varies. I've seen Renesas SH family, I've seen MIPS, I've seen PowerPC, I've seen ARM. Sometimes vendors will, running the same software stack, go from ARM to a different, will go between different CPU architectures in product cycles. So Dell's iDRAC 6 is ARM-based, iDRAC 7 is Super H-based, obviously. Running pretty much the same code, just rebuilt. The only exception in the wider world that's not running, so I say almost always running Linux. I've just realized I didn't actually check whether the Oracle ones are running Linux, but it wouldn't surprise me. HP run something called, I think, Green Hills, which is an embedded operating system. Everybody else is running Linux of various vintages, various degrees of quality, various degrees of competence. So these devices are there on your motherboard, and I just want to mention the on your motherboard thing a little more forcefully. These devices are built into your system, and if something really bad happens, you can't remove them and replace them. That's your entire motherboard has to be replaced if someone is able to do something particularly unappealing to your BMC. So now, going back from this kind of contextual stuff, I'm now going to start talking about IPMI as a spec again a little. IPMI has gone through a few spec revisions. 2.0 was released in 2004. 2.0 Errata 1 was released in 2014, which is, I think, one of the longer periods I've seen between a spec and its first Errata release. But there were previous versions of IPMI, and older versions were basically you sent a password over the wire and you logged in. They decided that that wasn't really acceptable, because these days we should encrypt everything, and everybody knows that cryptography solves all problems. So there are various parts of this that are handled in interesting ways. The spec actually has a bewildering array of different encryption protocols, different integrity protocols, different authentication protocols. But one of the amazing things is that as part of the authentication process, the BMC hands you the hash of your password. I'm just going to leave that here because I hate you all. No, that's not in the slides if it's true. I'm not doing it because the next slide's got spoilers. Anyway, this means that without authenticating, as long as you know a valid username for an IPMI device, you can connect, pretend to start an authentication session, and it will give you a password hash that's not very good, that you can then feed into, it is at least salted, so, and then you can feed that into a password cracker, and you can wait a while, and you can discover that the admin password is Hunter2. But it turns out that that doesn't matter. Because when I mentioned there's this bewildering array of combinations of encryption and authentication and integrity management, one of those combinations, which is called Cypher 0, and this was explicitly described in the spec and was noticed by Dan Farmer in this article that he wrote on how IPMI was one of the worst things that has happened in human civilization. One of these combinations contains no encryption, no integrity protection, and no authentication. As in, if you connect, you do not have to set up an encrypted session. You do not have to do anything to verify that the session has not been man-in-the-middled, and you do not have to provide a password. When this was noticed, this is a little bit upsetting, especially because a lot of BMCs don't let you change the usernames, and the username was then the only secret you had. Most vendors have provided updates that fix this. You should really make sure, if you manage any servers, that your BMCs are running up-to-date software. And you should then use IPMI tool to query them, to dump the currently enabled Cypher algorithms, and make sure that Cypher 0 is very, very disabled. It's marvelous. Isn't technology great? Aren't we, as a profession, on top of things? So, beyond the specification again, how do you... What?
There's AMI on that slide.
Oh, I'm sorry, I've got AMI on the slide. That's fine. There are two main vendors of this hardware. These vendors build on top of a variety of SoCs. AMI and Avocent produce them, are the two main vendors. Avocent are also known for producing KVMs. This is kind of how they got into that industry. AMI are a firmware company. The Avocent ones are used by Dell, IBM, and Cisco. AMI tends to be used by pretty much everybody else. Again, with the exception of HP, who have their own software stack. And use Avocent?
I have actually hardware that's nice.
Okay. There's a lot of commonality. If you pull apart the firmware images from, say, any of the Avocent vendors, you'll find that a lot of the code is clearly derived from the same base. There's an embedded web server called AppWeb. It has various modules that get loaded into it that manage various endpoints. So if you go to /data, it gets handed off to libdatahandler.so, and then there's something in there that parses that request. Vendors can then add additional plugins into that and have their own endpoint management. And this is fairly consistent. Bugs that I found in one vendor in this code tend to be present in other vendors as well. But to Avocent's credit, I've not found anything particularly egregiously bad in any of the common code that they've shipped. Now, I'm not saying that it's beautiful, amazing, inspiring code. It's written by a firmware vendor for enterprise customers. But it's fine. It's entirely fit for purpose. Then there's a lot of vendor-specific code on top. So on this, you tend to get a web UI, and people vary in what they use to implement the web UI. Some vendors do everything with CGI callbacks. Some vendors just have thin wrappers that call into the, for instance, Avocent provided functionality that does all the authentication. Some vendors use PHP. Some vendors use an extension of PHP that is incorporated into AppWeb that allows you to not merely embed PHP, but to embed C in your PHP. What could possibly go wrong writing stuff that takes untrusted input over the web in C? That sounds like a great plan. That does not sound like a great plan. You can usually SSH in, and then you'll get some sort of command line. As well as SSH, there's normally Telnet. These features, you can typically turn them on and off. There'll be non-UI web services like the ones I mentioned before. So anyone heard of WSMan? I really envy your lives. I wish I hadn't. WSMan is a specification that allows you to use web calls in order to get information about system state. So you can, for instance, call out and query whether your BMC has appropriate licensing. You can pull down the system firmware configuration. You can push new firmware configuration into the system. You can upload new licenses. You can get all kinds of great data out of it. Some vendors don't use this kind of thing and instead extend the IPMI protocol. IPMI has a couple of command bytes which are then for vendor-specific commands. And then after that, you embed a code that represents your company, and so there's namespacing of it. IBM, for instance, implement firmware configuration support by implementing something that's quite like a file system over IPMI. You send a open command with a path, and then you get back a handle, and then you can seek in that, and you can read it, and you can write to it, and you can close it. It's really like a file system. It's pretty awesome. It took me 3 days staring at TCP dump until I realized that, oh, the string of characters that I hadn't worked out, yeah, that's ASCII. There's not enough gin in the world. So, quick plug for another project I've worked on. Firmware configuration, there's this URL here. If you go there, you can download a Python module that allows you to write Python scripts that allow you to connect to the BMCs on Dells and Cisco's, pull down the firmware configuration, modify the firmware configuration, and then push it back out again. So you can completely configure the firmware on systems remotely. And this allows you to do automated deployment of systems rather than having to log into each one individually and change the firmware settings. I'll be adding support for the latest generation HP stuff in the near future. But that's not why you're here, really, is it? Really, you're here because you want to hear me get really, really angry and upset and just leave significant silences. So first thing first. If the code you're writing links against glibc, it's software. Okay, that seems pretty obvious, right? You do not get to get out of this by saying, oh, but I write firmware, not software. It links against glibc. It's software. Software is miserable.
Firmware's worse.
Software is really bad, and firmware tends to be worse than software because most people spend less time playing with it. There's much less external QA or bug reporting, anything like that. And honestly, if it works well enough, who cares? It's not like there's anything security sensitive here, is there? So you end up with situations like this, which is a pseudocode. Please ignore the fact that I'm not bothering to do any memory management here, because that would just be an effort. The original code did do memory management as opposed to just scribbling over random pointers. It probably also didn't just call getS, but for the sake of argument, it probably linked against readline instead. It's probably a GPL violation anyway. Can anybody see an obvious problem here that isn't a buffer overflow?
Looks great.
Yeah, you're missing a semicolon on the last line.
Oh, yeah, this. I am, in fact, missing a semicolon on the last line, and as a result, that's the only reason why this code would not compile and run. That is a completely acceptable objection. So you waved your hand. Sorry? System called with random arguments.
I think you should take your missing semicolon and put it in the arguments string.
Right. Apparently I should have a semicolon in the argument string. Well, anyway. This is what happens if you log into a Dell iDRAC 7 or early. I think this is an iDRAC 7 specific bug. You log in, you switch to this RACADM thing, and then whenever you type a command, it handles that command by re-executing itself with whatever you typed attached to the end of the binary name. So if you, for instance, type this, This happens. And now you have a root shell on the BMC. This is the BMC that, as I mentioned previously, is embedded into the motherboard and can't be replaced. So, to be fair, this does require that someone have valid credentials for your system in advance. Merely being able to reach it over the internet is not sufficient for this. And so you can say, well, they've already got admin credentials for the BMC. They can already do bad things. Being able to get a shell means that they can become persistent. Even if you then notice this has happened and change the credentials, they can log back in and change them back because they've probably backdoored stuff. If you attempt to do an install by uploading an ISO to the device, then they could have some code that modifies the ISO before it's handed off to the operating system. They can block any firmware updates you attempt to apply, so it looks like you updated the system in order to close the backdoor, but you actually didn't. That's an unfortunate situation. It's kind of bad. You should avoid being in that situation, and you should update the firmware on your BMCs. This is fixed. This was reported over 18 months ago. They released a fix over a year ago. How do I know? I reported it.
After applying the fix, how do you...
Oh, after the fix, you can attempt to SSH in, do this, and see whether it gives you a root prompt or not.
But they might have already prevented it.
Yeah, okay. It is difficult to prove that your BMC is trustworthy. Side note, the TCG specification for measured boot explicitly says that the security of BMCs is outside the scope of this document, and they are merely assumed to be secure. Someone decided to do their own XML parsing, and this is wonderfully for a login, and this means that at this point you haven't actually authenticated. This is you attempting to authenticate, and if you say do this, it ends very, very, very badly. Now, the good news is that I haven't figured out a way to do anything with this that doesn't result in us attempting to memcopy at least 2 gigabytes of data. And since the system only allocated a 60-byte buffer, that is going to segfault. So it's probably not exploitable. It is sufficient for causing the BMC to fall over for a while because it core dumps, and then it thinks, oh, I should gzip this core dump and store it somewhere. And these aren't very fast, so when it's gzipping a large core dump, it doesn't do much else while that's going on. Other things you'll find are, in some cases, implementations that are, shall we say, not written defensively. If you take one vendor's code and do this, I can't see any way that this could end badly. Again, to actually get at this, you need to be authenticated, probably. I'm still playing with a couple of bits there. I'm not actually going to drop any ODay here. Sorry. I practice responsible disclosure. Unless I'm in a bar, then, you know, anything goes. And then there are some things that just make no sense whatsoever. So, I mean, it's a good thing you'd never want to pass more than 6 arguments to anything. So you might be thinking here, the obvious thing to do is actually deal with the fact that you're going to have to leave your desk, go down to the data center, and turn computers off and on yourself, because these are not worth the hassle of potentially having to throw away every single server you own because they've all been compromised and are being used to mine whichever altcoins in fashion this week. So fine, just don't plug them in. That seems like it makes a great deal of sense. And then you discover that if you do that, they realize, oh, I'm not plugged in. I'd better bring up IPMI on the main system network port, piggybacked on another IP address, and just steal those packets. Which means your BMC is no longer on a separate network. It's now on your main network, and it DHCP'd. But it's fine, because nobody will ever find these things. And you think, okay, fine, we block IPMI, the protocol, at the border, so nobody's going to scan and find these IPMI endpoints. Which, yeah, okay. They tend to have predictable CNs in their SSL certificates, because they all generate new SSL certificates on boot, except for the ones that all use the same SSL certificate. Every single iDRAC 7 has the same SSL certificate, and the private half is in the firmware updates you can download from Dell. So, quick quiz here. Could everybody put their hands up? Right. Excellent. Keep them up for a moment. Now, if you think it would take more than a week to scan the entire internet and extract every SSL certificate from every system, actually, a week's ridiculous. If you think it would take more than a month to scan every IPv4 address and pull down the SSL cert, put your hand down. If you think it would take more than a week, put your hand down. More than 2 days? More than a day? More than 12 hours? More than 6 hours? More than an hour?
What are we searching with?
So there's like 4, yeah, you two don't count. Because I told you this already, and nor do you. So we've got maybe 5 or so people that think it takes less than an hour to scan the entire IPv4 address space for SSL certificates. And you know how ridiculous that sounds. The answer is 40 minutes. And the wonderful thing is, not only do they tend to leak the fact that they're a specific BMC, for convenience purposes, a lot of them embed the server serial number in there as well, which means you can scan, find all the BMCs that are on the public internet, and find the serial numbers for the server they're attached to, and you can then go to the manufacturer website, plug that into the warranty lockup tool, find the date that the server was purchased, find the exact model it is, from who is, you probably know who owns this as well, at which point you can call up the manufacturer, and you've probably got enough information to socially engineer them into telling you the default passwords for that system. So HP's randomly generate the passwords. HP's default credentials are an 8-character alphanumeric string rather than something that's consistent. It varies between systems, and so that's maybe something you could get an HP tech to tell you, but it's almost certainly enough to get HP to ship you some used CPUs or some RAM when you say that it's broken, and then you obviously run away with the RAM and CPUs. I recommend not doing that. Thankfully, the industry has realized that IPMI is not particularly attractive, especially because it's a pain to actually interact with. So we now have this thing called the Redfish specification, which is basically IPMI, except it's just a RESTful HTTP thing. And now you can turn your servers off and turn them on again in like 5 lines of Python. Which is... this is